So tell me a little bit about your switches. Tell me about the blue boxes.
Yeah, so we ended up, building a nice portfolio of switches, both rack mount and den rail mount switches. What's a little bit different than what you're used to with SDN in OT is these are purpose engineered, right? You're proactively traffic engineering the network to do the job that it's supposed to do. Like you said, it's fun when you're able to bring a solution that not only improves the cybersecurity, not only improves the reliability, but also makes the job of network engineering easier. No longer are customers sitting there thinking about VLANs or bridge IDs or path costs or RSTP convergence times. They're thinking about what type of circuits that they want on their network, right? It goes back to understanding what kind of conversations each device wants to have, and then just provisioning those circuits. I know like one of the cool things that we've seen from Veracity is the ability to profile hosts and apply those profiles so that a lot of that repeat work that humans typically don't like or not good at is handled within the software realm.
Yeah,
And the
absolutely.
switch gives you that programmable packet forwarding fabric now that is orchestrated by the controller. So the switches themselves will allow you to get, the flexibility of any of the interfaces that you want, copper, fiber, single mode, multi-mode, the power supply, rails that you need, and then of course the features that you're looking for, whether it's precision time protocol or power over Ethernet, being able to do that. The nice thing that you see with SDN is regardless of which switch you have, or even the mix of switches that you're deploying, from the controller or the network engineering perspective, it all acts like one big giant switch, because now you're just provisioning, I need a communication circuit from this source to that destination, go light it up.
Yeah. And all your switches are manufactured right in the US, right?
Yeah, so the cybersecurity piece is a big part of this, right? Because it's part of the reliability equation, right? With critical infrastructure, it demands reliability greater than 1,000-year mean time between failure. So cybersecurity is a big variable in that. So to be able to, have a secure supply chain and be able to provide the secure controls, the technology controls, go hand in hand. So SEL manufactures all of our electronic assembly in the United States, which allows us to control our source code. It doesn't go to a contract manufacturer. It stays within SEL and never leaves. We're able then to, validate the manufacturing through each of the phases, that we're getting the right raw materials. The raw materials haven't been, tampered with. We're using, the proper design in the product build, and then of course the final test. Have total control where R&D and manufacturing are working side by side to make sure that we're shipping the highest level of quality that we can to our customers.
Great. That's really nice. The final thing I wanted to ask you about is I've seen something marketed as a critical infrastructure switch, and I think my understanding is that kind of rolls up all the things you were just talking about.
It does. Yeah. So it really is just saying, it's a different solution, because when we talk about critical infrastructure, it's just to give you a couple examples of the challenges we have when we try to design a critical infrastructure switch. Is there are signal integrity requirements that the network can't be down more than 3 milliseconds, all the way to, the product can't have any moving parts. So we can't rely on fans to cool, thermal cool the device. And we need to work in extended temperature ranges. So the product needs to work flawlessly, from minus 40 degrees C to 85 degrees C, and combine all those things together and have a mean time between failure of over 1,000 years.
Nice. And there's a ton of certifications that you guys have on these switches as well, for everything from class 1 div 2 all the way, to the standard ones like UL and CE, but there's a whole lot of different certifications. So most environments that you'd want to put these switches in, they'd be a good fit. So
Yeah, we call it our torture tests for hardware. So we run it through the gauntlet of making sure that they can be installed in all the challenging, rough, rugged environments that we know that critical infrastructure solutions are in. 500 kV transmission lines running over top of the control house, or out in oil and gas platform out in the Gulf of Mexico. It has all of its environmental challenges with salt spray or other magnetic interference.